Hello chemistry fans, and welcome back to chemistry problem solving session for chemistry 1032. I am Dr. Russell Betts and I will be your host and guide through this problem. So without any further ado, let's come down to it. Alright, bag of salt, sodium chloride, has a mass of 575 grams. Calculate the molar mass of sodium chloride. Calculate the moles of sodium chloride in the bag, and calculate the molecules of sodium chloride in the bag. Ooh. All right. Well, I hope you watched the previous video, the supplement to this question, that talked about the molehill and how you have to convert grams to moles, paying the molecular mass tax, and going from moles to molecules, paying the Avogadro's number tax. This question basically uses that idea. And I hope you liked the video, and I hope that you liked the little fire-breathing dragon named Dr. Betts. Now, sodium chloride. Okay, so we have 1 times sodium, 1 times chlorine. So we get out the periodic table, we find that one mole, excuse me, of sodium is 22.99 grams per mole. And that chlorine times 1 is 35.45 grams per mole. So just calculating the molar mass of this is relatively simple. Just grab the periodic table, pull off the masses, and add them up. 22.99 plus 35.45 equals 58.44 grams per mole. And the MOL is the abbreviation for mole, but let me just put the E in there to make it a little more clear. All right, so that's how you calculate molar mass of sodium chloride. All right, now the next part says calculate the moles of sodium chloride in the bag. Well, we had to calculate the molar mass first, or we couldn't calculate the moles in the next step. All right, now we have the molecular mass, we can calculate moles. So let me set this up just using units. We have grams. We're going to multiply by something to give us moles of NaCl. So we're going to put grams of, NaCl, grams of NaCl on the bottom, moles of NaCl on the top. Grams go away, leaving us in the unit for moles. Let's plug in our numbers. The number 58.44 goes with the grams, so that's here. The number 1 goes up there with the moles, and there's the mass we start with, 575 grams. So now, bust out your calculator again. 575 divided by 58.44 equals, long string of numbers. So here we have to be mindful of our significant figures. Here we have 3 significant figures. Here we have 4. So the answer has to be rounded to 3. So it will be 9.84 moles of NaCl. So in that bag of 575 grams of salt, there are 9.84 moles of sodium chloride. All right, now the last step, calculate the molecules of sodium chloride. So if you remember the past video with the molehill, now we've gone to the top of the molehill, we've paid our mole tax, we're in moles, now we want to drive down the other side of the hill, and we have to pay the Avogadro's number toll. So to calculate the molecules, we know that in 1 mole of NaCl, we have 6.02 times 10 to the 23 molecules of NaCl. So that's our equality or our conversion factor. Set it up like this. Moles NaCl multiplied by something will give us molecules of NaCl. We're going to put moles on the bottom, molecules on top. And the moles cancel. Notice I never put numbers in till the very, very end. Numbers get confusing. Students, when they see numbers, they want to start punching them in the calculator right away. Resist the urge to put the numbers in until you set the units up. Once the units work, it's just a matter of putting the numbers in correctly. All right, so we're starting out with 9.84 moles. We know that the number 1 comes down here, and the 6.02 times 10 to the 23 goes there. Let's get out our calculator. 9.84 multiplied by 6.02 exponent 23 equals, and keeping in mind our significant figures, it will be 5.92 times 10 to the 24 molecules of sodium chloride in that bag. So that is how you solve that question. Let me write the answer down here a little bit cleaner because we had a little bleed through there. Let me use a black marker. It seems to work better. So the final answer is 5.92 times 10 to the 24 molecules of NaCl. 24. I'm sorry for the marker bleed through here. It's kind of challenging. There we go. All right. So that is how you solve that problem. Now, I hope that this has been helpful, and I hope that you were able to solve the problem and get the correct answers. If not, please see one of the many tutors we have here at the Academic Success Center, or come on by and see your professor during normal office hours. And with that, I want to wish you good luck and good chemistry.